Okay, so we are going to work on covering the basics of multiplying and dividing radicals since we have simplifying and addition and subtraction handled. So when it comes to multiplication and division, you have two properties, two rules that basically govern what we're going to do with radicals. And they're called the product property of, and we're again focusing on square roots, but this could be applied to any kind of radical. And we have the product property and the quotient property. So basically what both of those properties say is when you have radicals being multiplied, and so we have two radicals here being multiplied, we can use the product property to say that instead we're going to write them under the same root. So like if I had square root of 2 times square root of 3, I could actually write that as square root of 2 times 3, or in other words, square root of 6. Same thing with the quotient property, and so it's equality, so you can go either way. With the quotient property, I could have a numerator root and a denominator root that I can write all together as one root instead, or the opposite way. So if I was going the opposite, if I had square root of 1/4, I could write that as square root of 1 over square root of 4. And we kind of actually talked about that earlier in the year as well. I threw that in like really quick. But we have these properties that can be used to help us when the situation is necessary. So we're going to do this I do first off, and I know it looks like it's got a lot to it, and that's kind of what a lot of these radical problems have, is it looks like it's a lot, but if you kind of dissect it and use your properties, you'll be just fine. So the idea when you're multiplying radicals is, this is kind of the main focus, is that everything outside the radical, we're talking about just, if you look at the operations I just have multiplication. Everything outside the radical multiplies together, and everything, and then the same thing for inside, everything inside the radical also multiplies. So we're going to bring, it's like we're going to do a little bit of commutative property here. We're going to rearrange things. So 7 and 3 being on the outside, I'm going to rearrange those to be in the front of the radical. And then I have square root of 3y times square root of 30y cubed. Everything that, or what we just looked at as far as the property, I have two roots. The only thing is their index has to match, so they both have to be the same kind of roots. We have two square roots here. So if I take these two square roots, what I can do is I can multiply under one root the things in, or the terms in both of the radicands. So I can take 3y and square root of 3y and square root of 30y cubed, and I can multiply those together. So that would be square root of 90y to the 4th. The 3 and the 7 became 21, and now all I have to do is simplify. So 90 is 9 and 10, and I can take the square root of 9, which is 3. So I multiply 21 by 3 because I'm moving that 3 outside. So that is 63. And then y to the 4th is 4y's. So I can simplify that as y squared. Now there's still this 10 left inside. It's not a perfect square. It doesn't contain any factors of perfect squares. So my answer is 63y squared square root of 10. So everything that I had inside the square roots, the 3y and the 30y cubed, I multiplied and then simplified. And everything outside the square roots, I also multiplied and then used it to help me simplify. So the last thing I'll put here is it's multiply in roots, multiply out of roots, and simplify. So what you have to think about is the fact that we haven't just done straight multiplication this year. We've also done different forms of it. So this you do, I want you to think about what does that squared term, or what does that squared value mean? And then go ahead and, practice this one. So if you write this problem out, what you may notice is that it definitely could have been done in a shorter manner, but I really suggest writing these out to remind yourself, especially initially, remind yourself of, can I distribute that power or can I not? Well, if I rearrange things here, I have 2 times 2 outside outside the roots, and then I have root 5 times root 5. 2 times 2 is 4, and these root 5s can go underneath the same root, so that's 4 root 25, which is 4 times 5, which is 20. So in this case, when we have that squared, 2 root 5 times 2 root 5, all you have is multiplication, so there's no issue with the squaring. You could actually just shortcut it and say 2 squared and root 5 squared, but that's only because all you have is multiplication in that problem. So again, answer was 20. Okay, here's a second kind of problem with what else have we done with multiplying? We've also done the distributive property. So this is another you do to try. So pause and try this one. The answer would be, so we're going to distribute root 3. Root 3 is being multiplied by these parentheses. So we're going to take root 3 times 7. Notice how my 7 is not underneath the root. You need to make sure you distinguish, especially through this process. And then I have minus, and I have root 3 times root 8. Now 7 times root 3, we normally write this in this order. There's nothing we can do though. 1's in a root, 3 is in a root, and 7 is not in a root, so we're going to leave those separate. And then the product property says I can put 3 and 8 underneath the same root. So I have 7 root 3 minus square root of 24, and simplifying this, 7 root 3, and 4 is the perfect square, and 6 doesn't have any perfect squares in it. And if these worked out to be both root 3s or both root 6s, I would simplify it more, but as they are not like radicals, I can't combine them anymore. So we can distribute with radicals as well. The last multiplication here, that is the only place that gets any more complicated, is now you're going to, what other multiplication have we done? We've done foiling. We've done double distributing or foiling. So same method that you could do 4 plus x times 5 plus x, oops, plus, that's a plus sign, x is the same process we'll use here. Foiling this out. 4 times 5, 20. 4 times root 3, that's a positive 4 root 3. 5 and root 3 multiplied would be 5 root 3. And then I have plus root 3 times root 3. So I have 20 plus, these two are like sets of like radicals, so I would say that's 9 root 3. And then I want to simplify root 3 times root 3, which is root 3 times 3. You can combine those together, which is root 9, which is 3. So if I go ahead and simplify that piece, kind of writing these steps off to the side, then this would turn into 3. And I have like terms at 20 and 3. So that would be 23 plus 9 root 3. So foiling, distributing, we've done both of those many, many times this year, and now we're just doing that with radicals. So the thing that you have to remember is inside radicals, if it's inside a radical, a square root, it's going to multiply with other things with its square roots. If it's not in a square root, it's kind of like they're incompatible. They can multiply together. You can have 4 times root 3, but you're not going to multiply those two together in a different form. So here's one for you to try as our last example of multiplication. If you're careful with the squared here, it's going to matter. So if we write this out, 9 plus root 2 times 9 plus root 2, you've got to remember what the squaring means. This is the only way to multiply this out, is to think of that foiling process or think of the distributing process. So 9 times 9, 81. 9 times root 2 is 9 root 2. 9 times root 2 is another 9 root 2. And then the last one here is plus root 2 times root 2. So root 2 times root 2 is really root 2 times 2, because product rule says I can put them under the same square root, root 4, which is actually 2. So I have 81 plus these two like radicals. Oops. I was meaning to write 18 there. Plus 18 root 2 plus 2, so that's 83 plus 18 root 2. Normally, the accepted way to write these is to leave the radical term at the end. But again, we can't combine these now because they're not. This has a root 2 on it, the 18 root 2, and this has no roots on it at all. So that's pretty much all the multiplication we've seen, and we're just kind of adapting it to radicals. So going into division now, how does the division property look maybe different or look the same? The thing that I suggest most is starting with, no matter what form it's written in, start with the radical over the fraction. So in this case, we have the fraction inside the radical. One of the rules we had for simplifying radicals was if you have a fraction inside a radical, you are not totally simplified. I suggest starting with that, and we'll see why in just a second. And once you've got that, you want to try to simplify that fraction. Start with that, and then try to simplify. Now here, 20 over 49, those two numbers don't have any factors in common. If that doesn't work, if there's no simplifying that can happen, then you want to then split into a root on the numerator and a root on the denominator. So root 20 over root 49. And simplify there. So it's like you want to try simplifying the larger fraction first, and then try simplifying differently there. So if we have square root of 20, that's 4 and 5. So square root of 4 gives me in the numerator 2 root 5. In the denominator, I have square root of 49, which is a perfect square, so that would give me 7. Now, if I were able to simplify here, the only place I could simplify would be the numbers outside of the root. I cannot divide, so division cannot occur with a number in a root divided by a number out of a root, or the opposite. You can only divide within roots or outside, just like the multiplication. So to see kind of a different type of problem, now this one is written as 2 individual roots. If I start with this in one large root, one large radical, now I'm going to try to simplify this fraction. So m to the third is 3m's. So what can happen here is I can simplify, and if you remember your exponent properties, you might be able to get this a little sooner. But if I can cancel out, I have a factor of m and I have a factor of m here. So what I'm really have now when I simplify is m squared over 9. If you remember, because we have division here, you can subtract the exponents to get to your solution. Now, once I've simplified, I'm going to split up the m squared and the 9, and then I'm going to simplify them individually. Square root of m squared is m. The square root of 9 is 3. So m over 3. Sometimes you may be left with a radical, and sometimes. So I have one question here for you to try. Now this one looks harder, but if you follow the steps we just talked about, simplify the radical first, the problem should be easy. So we have two rules involving division about when we're simplified. Number one, we can't have a fraction inside a radical, and the other one is we can't have a fraction that has a radical in the denominator. So if you make this into one big fraction underneath the radical first and then simplify, you're going to be in better shape. So we have 2 and we have 5 x's. We have 32 and we have 2 x's. 2 x's are going to cancel. But then you also have this 2 over 32. So 2 over 32, both are divisible by 2. So we can divide by 2 in the numerator, and we can divide by 2 in the denominator. Simplify that fraction. So that leaves us with 1 x to the third in the top, in the numerator, and 16 in the denominator. Now when we split this up, x to the third over square root of 16, the numerator is x root x, and the denominator is 4. None of our rules are broken. We don't have a fraction in the radical anymore, and we don't have a denominator with a radical.